In this program, we'll use the temp sensor and the LED strip to create a thermometer that shows more pixels on the strip the warmer it is. Anytime we use the LED strip, we want to include the LED strip.h library. A code library gives your program access to special functions that are exclusive to the LED strip. For example, strip.setPixel and .draw. To use the LED strip, we also need to give it a name. I name mine strip because that's easy for me to remember and easy to type. We also complete this LED strip function, and it has three arguments. First, how many pixels are on the LED strip. Second, which pin of MakerBoard is plugged into the green wire of the LED strip. And third, which pin of the MakerBoard is plugged into the blue wire of the LED strip. Within the void setup function, use the pin mode function with arguments A1 and input to set up your temperature sensor. This is in the smaller block of ports at the bottom of MakerBoard. And make sure you review the parts list or the component card for the temp sensor so that you get it plugged in the right way. Within the void loop, the first thing we'll do is create a variable. This is going to be an integer type variable, shortened to int, and that means it can only be a whole number. Next, we name the variable, and I've named mine tempf because that's what this variable is going to stand in for, the temperature in Fahrenheit. After a single equal sign, we give the variable its starting value. This variable's value has two parts. First, we take the reading from port A1. That's where the temperature sensor is plugged in. But the temperature sensor sends in a voltage value, not a temperature value. And so we multiply that by 0.46, which gives you a pretty accurate temperature in degrees Fahrenheit. On line 13, we immediately change the value of the tempf variable. We do that with the map function. The map function allows us to match up different ranges of values, even if those ranges are of different sizes. In this case, we want to convert the degrees of the temperature reading into pixels that are lit up on the LED strip. The map function has 5 arguments. First, the value that we're mapping, that's tempf. The second argument is what's the lowest value you want to use in the range you're mapping from. So I want my thermometer to be able to read a minimum of 60 degrees. I don't think it's going to get that much cooler than that on my thermometer. The third argument is what is the maximum value from the range that you're mapping from. For me, that's 80 degrees Fahrenheit because I don't think my thermometer is going to have to read much higher than that. The fourth argument in map is what is the value you want to map the second argument to. In this case, when I have a tempf value of 60, I want to map that to a value of 0 so that there are no pixels lit up on the LED strip. The fifth argument in map asks what value do you want to map the third argument to. So when I have a tempf reading of 80, I want to map that to 14 because I want to light up to pixel 14 on the LED strip. After we've changed the value of tempf to have a range of 0 to 14, use the strip.clear function to clear off any pixels that are lit up on the LED strip currently. Next, we have a for loop. The for loop has 4 main parts. First, you create a variable and give it a starting value. Then, you create a condition that is checked each time the for loop runs. Third, there's a change to the variable that happens after the code between the curly braces runs. And fourth, there's the code between the curly braces that runs when the condition of the for loop is true. The variable I've created here is an integer, shortened to int, and it has the name I. I is a really common variable name to use when you're just counting how many times a for loop is running. I has a starting value of 0. The condition checks is I less than temp F, and the change to the variable is I++, meaning that after the code between the curly braces runs, I will increase by 1. The code between the curly braces here is a setPixel function, and it has 3 arguments. The first argument is which pixel on the LED strip do we want to light up. You could use a number here from 0 to 14, but we're using the value of the variable I, and that value is going to change as the for loop runs. The second argument is a color value that we want to show on that pixel. I chose 200, but this can be any number from 0 to 299, and those each correspond to a different color that the LED strip can show. The third argument is a brightness value for the pixels that we're lighting up. This is like a percentage, so 0 here is 0 brightness, 100 is maximum brightness, and 10 that I'm using here is 10% brightness on the LED strip. We don't always use this third argument, and it's called an optional argument. If you don't type anything here, we use a brightness value of 100. The reason that we want to use a brightness argument of 10 is that the temperature sensor sends in a very finely tuned voltage to the program. If you turn on a lot of the pixels of the LED strip, that requires voltage that may mess up the reading from the temperature sensor. So if we set the lights somewhat dim, we're drawing less voltage when we use the LED strip, and we can get better temperature readings. After this for loop has run and is complete, there's a strip.draw function that will show on the LED strip whatever pixels need to be lit up. Next, there's a delay of 1000 milliseconds or 1 second before the void loop ends with this closing curly brace, and the code jumps back up to line 12 and takes a new reading from port A1, multiplies it by 0.46, and now we have a new value for temp F. On line 13, we'll use the map function to map that value to a number from 0 to 14, clear off the strip, and then use the for loop to decide how many pixels to light up. Let's look at how this void loop might run with the different temperature readings. Imagine that the temp F is 70. On line 13, the map function is going to map 60 to 0, 80 to 14, and so 70 is going to map to 7. The strip.clear function clears off anything that's already showing on the LED strip. And then in the for loop, you create the integer variable I and set it equal to 0. 0 is less than 7, so the code between the curly braces is going to run, setting pixel 0 to a color value of 200 with a brightness of 10. And remember that pixel 0 is the one closest to the wires that plug into your maker board. When the end of the for loop is reached, I++ runs, increasing the value of I from 0 to 1. 1 is still less than 7, so the code between the curly braces runs again, setting pixel 1 to a color value of 200 and a brightness of 10. This is going to continue until you light up pixel 6. After pixel 6 lights up to a color value of 200 and a brightness value of 10, I++ is going to increase the variable from 6 to 7. 7 is not less than 7, so the code between the curly braces is skipped, and the strip.draw function will display pixels 0, 1, 2, 3, 4, 5, and 6 lit up on the LED strip. After a delay of 1000 milliseconds, the void loop ends and the code jumps back up to line 12. Now imagine that temp F has a reading of 80 degrees Fahrenheit. On line 13, the map function is going to map 60 degrees to 0 pixels and 80 degrees to 14 pixels. So we are now going to have a temp F value of 14. Strip.clear clears off the pixels that were written the last time the void loop ran. And the for loop is going to start again. I equals 0, And because 0 is less than 14, the code between the curly braces will run. Again, setting pixel 0 to a color value of 200 and a brightness of 10. This loop is going to run 15 times until I equals 14. After the 14th pixel is lit up to a color value of 200 and a brightness of 10, the condition will be false because 14 is not less than 14. The code between the curly braces is skipped, and the strip.draw function is going to display all of the pixels on the LED strip lit up. Then the code reaches a delay of 1000 milliseconds, or 1 second, and the closing curly brace of the void loop, before jumping back up and taking another temperature reading.